is Richard Schmidt. My project is on hurricanes, as you can see in the photo right there. Um, my question is, does warmer sea surface temperatures in the Gulf of Mexico cause tropical cyclones to strengthen before land? Um, it's a very interesting question because in the past there have been tropical cyclones when they come close to land, they weaken. Why do they weaken? And then other tropical cyclones strengthen or they maintain their strength and they'll strengthen even more right before landfall. So I've always wanted to know answer to the question. So I decided to do this study. So let's see what we see. So I made this from observation. I didn't go look this up and good hypotheses start from observation. So since 2018, there has been several hurricanes that have hit states bordering the Gulf of Mexico that have strengthened before hitting land, some even rapidly strengthening. And the examples of the storms include Hurricane Michael, which was a Category 5 that hit Florida, Hurricane Laura, a devastating storm that hit Louisiana in 2020, Hurricane Zeta, which was a late October storm, Hurricane Ida, another really bad storm that hit Louisiana in 2021, and Hurricane Ian hit Florida. Hurricane Idalia hit Florida as well, and even Hurricane Francine, which hit Louisiana in 2024. But conversely, not all landfalling Gulf hurricanes of the past have strengthened before landfall. In fact, some, including strong storms like Hurricane Katrina and Hurricane Rita, have weakened before landfall. And that's kind of surprising to some people who think that, because Hurricane Katrina was so destructive. But it actually was a Category 5 in the middle of the Gulf, and as it got closer to the coast, it actually weakened to a Category 3. So when you think about if it didn't weaken, how much worse the damage would have been, it would have been a lot more wind damage. I mean, the water damage was horrible. It was very, very severe. But if it wouldn't have weakened and maintained its Category 5 strength, the damage would have even been worse. Other hurricanes that have weakened before landfall include Hurricane Opal back in 1995, Hurricane Dennis in 2005, and Hurricane Lily back in 2002. So my question is, are most recent storms strengthening because of warmer Gulf of Mexico sea surface temperatures? That's interesting. You hear about, global warming, Gulf getting warmer. So my question is it causing these storms to strengthen? My hypothesis will try to answer this question. I will try to prove that Gulf hurricanes are strengthening before landfall because of increased sea surface temperatures. So, Gulf storms from 2002 to 2010 will be studied by using GIS maps to study the strength of the storms and the underlying Gulf Sea surface temperatures. So we want to combine those together, strength of the storm and the sea surface temperatures. See if we can come over with a relationship to see if the storms are strengthening or not strengthening. And also, we want to look at Gulf storms from 2016 to 2024 will be studied by using the same software GIS maps to study the strength of the storms and the underlying Gulf Sea surface temperatures. The reason for the lag time, so we have about a 6-year lag time, is to see if the warmer Gulf is in part causing strengthening storms near the landfalls. Because, if we, from past research we see about global warming, about the Gulf getting warmer. So let's see if that's really happening and how is it affecting the way that the storms are strengthening or weakening. Let's see what's going on. Quick literature review. Warming of sea surface temperatures and hurricane development is certainly one area of study as warm water tends to fuel hurricanes when other conditions are right. So there was a study by Holland who took the means of climate simulations ensembles with gases and aerosols and subtracted the ensembles without the gases, developed an index known as the Anthropogenic Climate Change Index, ACCI, to see if the global warming and higher sea surface temperatures have contributed to high tropical cyclone activity. While the frequency of the tropical cyclones wasn't affected, the study did find an increase in Category 4 and 5 hurricanes, while interesting, a decrease in 1 and 2 hurricanes. That's from Holland. Another study by Rappaport analyzed Gulf of Mexico cyclones from 1979 to 2008 and their intensities from 2 days until landfall, and noted the hurricanes of Category 1 and 2 strength tended to increase before landfall, while stronger hurricanes of 3 to 5 tended to weaken. Interesting. It included storm estimates, ocean heat content, and other atmospheric models using ship model databases from Rappaport. Uh, the study found that regions in the central Gulf of Mexico had higher deep mixed layers of heat, while the northern Gulf had a decrease in heat. Another study from Wang showed that the global landfalls of intense tropical cyclones is increasing. However, they were unable to determine if this was related to climate change or some other variability of the climate. That's from Wang. Um, Knudsen assessed climate models that showed a 2-degree global warming increase and the effect on tropical cyclones. So that's from the models. The study determined that storm surge and sea level rise would be higher. Tropical cyclones would produce more precipitation and more intense tropical cyclone strengths. So that's very interesting as well. Okay, so continuing the literature review. So Hurricane Ida in 2021 and Hurricane Katrina in 2005 were two strong storms that struck Louisiana. Hurricane Ida strengthened until landfall as a Category 4 storm, while Hurricane Katrina weakened from a Category 5 storm and struck Louisiana as a Category 3. Regardless, both storms were extremely destructive. And one of those storms I went through, that was Ida, and there was a lot of wind with that. So I know offhand how it was. Zoo study from Zoo compared both Hurricane Katrina and Ida, which was interesting. While sea surface temperatures were high for both storms at landfall, vertical wind shear had increased for Katrina, being one of the contributing factors for a decrease in strength. Sea surface temperatures for Ida was slightly higher close to the coast, but about zero point 0.5 degrees Celsius. Uh, it was slightly higher, about zero point 0.5 degrees Celsius. And an eye wall replacement cycle occurred close to land for Katrina, which contributed to its weakening. And relatively humidity was higher near the shore for Hurricane Ida. So that's interesting. You see the different little factors like that can impact why a storm could strengthen or could weaken. And that was from the zoo. So methods and data for my project. Data was taken using ArcGIS maps that consisted of two primary layers: sea surface temperatures and strength of storms. Sea surface temperature data source comes from NOAA Coral Reef Watch. The cell size is 0.5 degrees, 0.5 degrees, 5 kilometers. Data is taken using a daily satellite, and it's recorded from 1985 to 2024. Pixelated colors represent the sea surface temperature. The darker, the warmer in this map right here. This is a warm Gulf on 7/18/24, so you can see pretty warm Gulf. And the data source again is the NOAA Coral Reef Watch and ERSI. The other layer I used is historical hurricane track layer was placed on top of the SS of the sea surface temperatures and studies. Each track included storm strength and location along with dates. The data source for the hurricane tracks was NOAA, and the owner was a federal user community. If you look at this map right here, you can see this is Hurricane Katrina's strength donated by the color of the lines. So if you look at the dark red in the center over here, that is Category 5. That's the highest strength where it reached. But as you can see, as it gets closer to land, it does weaken. So each color of the line represents strength. Notice how the storm peaked in the central Gulf but weakened as it came close to land. So here's more of the methods and data. I just wanted to show you all this. So I studied each part of the line right here. I got the strength using the GIS software. It shows you a Katrina strength at this point of location, 125 knots. And at the same time, you can get the sea surface temperature underlined on that same area. So at that point in the Gulf, it was 29.63 degrees Celsius. So I did that all across the line. But I didn't do the entire line. I did about 150 miles from landfall because I wanted to see how storm strength and how sea surface temperatures were related close to landfall, 150 miles and up to the landfall, because that's what I was seeing. Why the storms are strengthening at near landfall, or why they're weakening. Trying to develop a relationship here. So methods and data continuing. Data on sea surface temperature and strength of storm were recorded on all Gulf storms from 2002 and 2010. Excluded were any unnamed storms. I tried to exclude outliers. And a lot of those unnamed storms, sometimes they form in December, November, or they're extratropical. I didn't want anything skewing the data. Because I was interested in how strength changes near landfall, only 150 miles of the track data were recorded at selected intervals. The distance GIS tool was used to measure each storm track from near 150 miles to landfall point. Strength and sea surface temperature was collected along the track at selected intervals and on the same date as well. We wanted to make sure that the date and the strength were aligned. We don't want that. That would make most sense if we want to develop a relationship here. The process was repeated for all the Gulf storms from 2016 then to 2024. And again, unnamed storms were excluded. So after the data was collected, the storms from 2002 to 2010 and from 2016 to 2024 were compared. Using Excel, we started with simple central tendency statistics first to analyze the storms. So what we found is the average sea surface temperatures for storm tracks recorded close to land from 2002 to 2010 was 28.60 degrees Celsius. The average sea surface temperatures for storm tracks recorded close to land from 2016 to 2024 storms was 29 degrees Celsius. So it did go up. It wasn't a lot, but it did go up, and I consider that a substantial amount. Thus, Gulf water temperatures had increased for 2016 to 2024 storm tracks by 0.4 degrees Celsius. So the ranges of each storm strength were recorded. For example, if a storm started at 100 knots but weakened to 75 knots near landfall, the recorded data was negative 25. Vice versa, if the storm started at 75 knots and strengthened to 100 knots, the recorded data was plus 25. Ranges of these storms were then summed. From 2002 to 2010, this total strengthening of the storms based on the sums was a positive 74 knots. But get this, and this is a big deal for me. From 2016 to 2024, the total strengthening of storms was 291 knots, tripling the value of the storms from 2002 to 2010. So right there, that shows me that there's definitely more strengthening of storms in the later period. Also, average wind speed of data recorded on storm tracks from 2002 to 2010 was 61 knots. Average wind speed of data recorded on storm tracks from 2016 to 2024 was 69 knots. So that's an increase right there. That's important to note as well. Then we did a correlation test. So we wanted to get a little deeper in the statistics. A correlation test was used on each time period to compare the storms. Two variables were compared: storm surface, sea surface temperatures, and the range of strengthening or the weakening. So those are the two variables we compared to try to see if there's some kind of relationship. What we found for the period from 2002 to 2010, the correlation coefficient was 0.41. Then we did it for the later period, 2016 to 24, and it was 0.43. So those numbers do show a positive relationship between sea surface temperatures and strengthening of storms. However, it wasn't big as I thought, especially for the later period. I thought that number was going to be more positive because we've seen the increase in strength and things. I'm going to get into that in a second. Conclusion. From the data, Gulf water temperatures along the storm tracks have increased from 2002 to 2010 and to 2016 to 2024 by 0.4%. To me, this is substantial, even though it does seem like a small number, but considering that storms were sampled from June to November, I think that's pretty substantial to me. Storm strengthened much more, over 3 times as much near landfall. So that means, it increased 3 times as much near landfall in 2016-24 than 2002 to 2010. This means that storms are growing stronger near landfall instead of weakening. Instead of, majority strengthening, weakening. I'm not saying there's not weakening storms. There is. But it seems like the majority of these storms are strengthening more. Examples of strengthening storms include Hurricane Ida, Hurricane Helene, and Hurricane Michael, which is a Category 5 monster. Also, average wind speeds of storms on recorded tracks increased by 8 knots from 2016 to 2024. I need to word that better. It increased by 8 knots from 2002, 2010 to 2016, 2024. correlation tests showed a positive relationship between storm strengthening, range, and sea surface temperatures for both periods, although not as high as expected. I especially thought the correlation coefficient would have been higher for the later period. Thus, can I say with utmost confidence that warmer Gulf temperatures are causing storms to strengthen? Because the coefficient isn't higher, the answer is no. My assumption is that there are other factors at play besides sea surface temperatures that may be causing storms to strengthen or weaken. This can include upper level conditions, amount of wind shear, because tropical storms they don't like wind shear. They want little change in wind with height. Eye wall replacement cycles, those can weaken storms. Size of storms can have a lot to do with sometimes its strength. If a storm is very big, can cause cooler water with upwelling, but a smaller storm can strengthen quicker. Amount of dry air in the atmosphere. Tropical storms do not like dry air, so if there's some there, that can cause uh, weakening, no matter even if the sea surface temperature is high. Also, upper level energy and diffluence. That's taking away winds in the atmosphere can sometimes strengthen storms. And one example I have, just for reference, is from the 2016-24 data. Hurricane Zeta was a late October storm that moved over relatively cooler Gulf sea surface temperatures, but not cold. But it was late October. However, the storm strengthened from a Category 1 to a Category 3 pretty quickly before hitting Louisiana. Thus, it appeared that other factors besides sea surface temperatures helped strengthen the storm. That's important to note. So, conclusion. While Gulf sea surface temperatures are increasing, along with strength of storms near landfall, I cannot say with complete confidence that it is because of increasing sea surface temperatures alone.